racing. I am working on a rear bed cage for a vehicle like a Toyota Tacoma or Ford F-150, a Maverick, a Raptor, what have you. What's cool about this thing is that it is going to be a DIY weld kit with a lid on the back, a rear hatch, if you will, that will bend upwards and downwards and go along that little pivot point right there. And what's extra cool about it is DIY. I designed the kit, you buy the kit, it's shipped to the pallet straight to your door. And the biggest question that most people are going to have is, one, how did you design it? And then two, how do you actually make the kit suitable for laser welding? Because if you actually just buy um, parts, there's an extra level of work that's done. You see like this joint right here and how it looks picture perfect to these two tubes. Well, this tube is more realistic. Do you see these two edges right here? Those are called normalized profiles, normalized edges, and that's actually something you can weld. This right here is a perfect in a vacuum type joint prep that is what most software is known for. So I am going to take this profile of this tube and make it something that is not only laser cuttable but weldable. So we are going to be working with ruled surfaces, and I'm going to be making a normalized profile everywhere I can. This one's going to be kind of easy. The next side should be a little more difficult. I'll walk you through both of them, but you see this ruled surface profile right here? That is going to be something that we're going to be using throughout this video over and over and over, and it's a pain. I'm trying to make a normalized profile to the diameter of the pipe, to the surface area of the pipe. It can be from the inside, it can be from the outside. You can see these extending over the edge. Those are coming from the inside. This one that's going to the ID is coming from the outside. The goal is to have it carve as much material away from the joint prep while keeping it square, while keeping a good tolerance to it. The tool that we're going to be using in the surfaces feature is called the replace face. And this is going to let us choose a surface, take our ruled surface that goes along with it, hit enter, and it replaces that surface with the profile you have selected. Anytime that you have actually used a ruled surface, go ahead and hide it so then you don't get distracted by it for the remainder. But I'm going to now replace this surface with the ruled surface coming up from the ID. Hit check, and now that surface goes away. We come over here, let's click this surface here. Let's replace the face again with the ruled surface coming from the ID. Hit enter, and whammo, we now have a surface that is prepped and ready for laser welding. Now, these little humps you see right here, those little notches, that actually might be a point where the laser gets confused. You know, it doesn't interpolate right and doesn't cut its path. So if you want to make it a little easier on yourself and the laser cutter, you can actually cut a fillet out of that. You can choose how sharp your fillet is going to be, the radius of it, hit check, and now you have a smooth surface that the laser beam can follow. So now let's fix that profile over here. All right, we're now on the second side of this pipe. Let's create a ruled surface. Let's change that distance and direction. And you see how this is kind of like highlighted yellow right here? If it was really pronounced, that would be something that we would have to take care of, but we don't have to right now. Same case with this one. This is a pretty easy tube, all things considered. So those ruled surfaces are there. Let's replace the face. It's going to automatically select your previous ruled surface. I like selecting as much of the material as I can, so that can cause a glitch. So I delete it every time or deselect it before I switch to it. Great. Let's go back to let's select this face. Let's use replace face again. Hit this ruled surface, hit check. All right, we are now done with this tube. Might as well add our fillets right here. 1, 2. They don't have to be super aggressive or gradual. You're just trying to create a more gentle transition for the laser beam to follow. Remember, you're trying to get this ready for laser cut. We are going to exit the isolate, and now you can see that this tube has been prepped for a good joint prep and good weld prep. I'm going to zoom out and show you the before. This is the before, the idealized picture perfect computer model. And now this is the real world practical, I can get this done and actually turn it into a weld prep type joint. And you will see these over and over again on my model. And when I am done with all of this work here, finishing the laser prep of these last few parts, I've got 1, 2, 3 to go. I will show you how to export all of these files at once as in each individual tube to get laser cut. I'm Nate from Good Mayhem Racing. I will see you out in the desert, if not my garage. Like and subscribe for more.